Okay, a video reviewing triangle sum theorem and external angle theorem. Alright, so triangle sum theorem is taking each interior angle of a triangle and knowing that they add up to 180 degrees. We have two different types of triangles we're going to look at. We have the equiangular and equilateral triangles. Remember, an equiangular triangle has all three angles of the triangle being congruent. So in that case, all these would have to be 60 degrees for them to add up to 180 degrees. And an equilateral triangle means that all three sides of the triangle are going to be congruent. And remember that relationship between angles and sides, that if you know that one angle is 60 degrees and you have another angle that's 60 degrees, their opposite sides are going to have to be the same length, because there's always a relationship between the degrees of the angle and its opposite side. Isosceles triangles have two sides that are congruent, and the angle that is opposite of that side, so if you draw a line through the middle of the triangle, the angle that you hit is its opposite angle, and same thing here. These two angles have to be congruent based on that relationship I talked about in the other triangle. That if you know two sides are congruent, their opposite angles would also have to be the same. There's always that relationship between the angle and its side. As an example, let's say this was 50 degrees and this was a length of 10. If these two are congruent, this has to be 50 degrees, this has to be 10, because across from this 50 degrees was 10, so across from this 50 degrees also has to be 10. And that's an isosceles triangle. All right, so in this problem it says, given an isosceles triangle, find x, y, and z. So it's isosceles, which is letting us know that this side and this side are going to be congruent. I can tell those two are congruent by looking at the picture. These two are definitely closer to the same length than this one up here. This one's definitely nowhere near the same length as the other two visually. That means also that since these two sides are congruent, the angles opposite of them, so this one here, is going to be congruent to this one here. Those are called base angles. So if we know this one right here is 28 degrees, this one over here is also 28 degrees. So to find our other angles, we can use our triangle sum theorem that all three angles, this one, and this one, have to add up to 180. So if I know there's a total of 180 degrees, if I subtract away the two that I know, what's left over would be the third angle. That's going to be 124 degrees. So I now know that this angle x is 124 degrees, because all three angles inside the triangle have to add up to 180. I can also know that angle y and the 28 degrees, these are called vertical angles. Vertical angles are made when they're opposite of each other, and you'll always notice there's like an X drawn with the two lines, and the two that are opposite of each other are always the same degree. So if this is 28, this is 28. So now I know what angle y is. The last one I need to find is this angle z over here. Now keep in mind that we have a straight line here. And if you have a straight line that has a total from here to here, 180 degrees. Remember, straight lines are 180 degrees. Now I know this section. This is 28. So if the whole thing's 180 and this part's 28, if we take away 28, what's left over is the angle z that we're looking for. So 180 minus 28 is going to be 152 degrees. So angle z is 152 degrees. All right, for this one, it says given a triangle, solve for x. By looking at the markings, we can see this is a equilateral triangle, which means all three sides are the same, and it's also equiangular, that all three angles are the same. which means angle 2 is actually 60 degrees. Well, if we know angle 2 is 60 degrees, and they let us know that the measure of angle 2 is represented by a 10 plus 5x, since this is representing the 60 degrees, we can set them equal to each other to solve for x. And then I just solve. Minus 10, I get 50, divide by 5, and I get 10 for the x. All right, so for this one, it's given us a triangle, and they asked us to find the length of JL. So we're going to try to find this length here that I'm marking in purple. But before we can find it right away, we actually need to figure out what x is. Now you'll notice that we have these two marks here and here, which is letting us know this is an isosceles triangle because there's two congruent sides. If these two sides are congruent, these two lengths are equal. So I can set these two expressions equal to each other. So I can do the 3x plus 20 equals the 5x plus 6. All I have to do is solve the equation. So I'm going to minus my 3x over to my 5x. I'm going to get 2x. I'm going to minus the 6 over to the 20, which is going to give me 14. Divide by 2, and x is 7. Now that I know that x is 7, and I'm looking for JL, I can plug it into this expression, which represents JL. So JL is equal to 4x plus 22. And just filling it in, so 4 times 7. 4 times 7 is 28. So 40 and 50. So JL has a length of 50. Exterior angle theorem is basically telling you you have these two remote interior angles, which is angle 2 and angle 1. You can add them together, and it will equal the angle that's outside of the triangle. So what does that look like? Let's say down here I'm trying to find this exterior angle where I drew the question mark. All I need to do is take the two over here, the 38 and the 67, and add them together. That's going to equal my angle that I'm looking for, the exterior angle. So 38 plus 67 is 105. So that means this angle right here is 105 degrees. So if we're looking at this one, we need to solve for x, and we can see that they have given us this angle over here. They've given us this angle over here. And they give us an expression for the exterior angle. Once again, if you take the two remote interior angles, this one here and this one here, if we add them together, it's going to equal the exterior angle. So our symbol here means 90 degrees. So we have 90 degrees plus our other remote interior, the 2x plus 1, and that equals the exterior angle, which is the 6x minus 9. I'm going to go ahead and solve. So 90 plus 1 is 91. And then I just solve, continuing, minusing the 2x over. So I have 4x, add the 9, you get 100. And you get 25 for x.